those who are not familiar with LLMs and search applications, there are many compartmentalized or containerized search applications that can be used now. And these can be very beneficial, especially with large graphs and databases, because they enable the user to be able to quickly search and find data that is related to the issue that they are exploring. But an LLM is certainly not required for a digital twin. Most digital twins, when they are first built, are built to prove capability and to deliver initial business value. They are not built around AI or ML solutions. However, as more and more data sets are connected to a digital twin and use cases become more complex, machine learning models and in-house models also need to be able to be connected to users. And so the digital twin often becomes the product wrapper for data models that are created by data scientists. And in this way, users, especially users in the field and frontline managers, can consume data products without the organization needing to build more and more bespoke products in-house. All innovation should have business benefits and user benefits. In this case, for the visualization twin, it is really about situation awareness. The fundamental goal of the visualization twin is to be able to give users the ability to collaborate across functional silos. Often the first users of this system in a mine site, for example, is production and maintenance working together in pre-start briefings and at the end of briefings and debriefings. And we find that when we implement a system like this, the management of change for the site workers and central office and engineering workers is very important. And so the implementation of a digital twin almost always includes business process re-engineering. And that is why digital twins are typically considered a tool of digital transformation. Implementing a digital twin without business process support is very often a failure. As a reminder, we come back to the definition of digital twins being effectively a decision support tool. So we design the system to improve decision making, and then we build the elements of the twin required to create the outcome for the user. This writing may be a little bit small for some to read, but I'm happy to provide this presentation afterwards as well. What I'm showing here are some example asset owner use cases that we have either built or been involved in building. So you can see the visualization twin, which is typically for operations and maintenance. In the center is the improved handovers, which is really about making the transition from large CapEx, major capital projects, into the operations and maintenance digital twin. And in this way, the operations and maintenance digital twin is always kept up to date. A constraints twin is a type of twin that uses a theory of constraints logical model. And the constraints twin identifies bottlenecks in near real time through production processes. So this is a very powerful twin, especially for where production losses are occurring and there are challenges with faults or recurring faults. A constraints twin will often show that it is not equipment faults that is causing production losses. It is other factors or issues such as planned maintenance occurring at the wrong time, planned maintenance or shutdowns running long, lack of ore, lack of feed. So a constraints twin is a very powerful tool for maximizing production. Another type of tool that is associated with operations and maintenance is improved work. The improved work twin takes the scheduled and planned maintenance work and the production planning and shows it visually at a very detailed level so that operations and maintenance can collaborate around the scheduling of work and the scheduling of production. The second part of the improved work twin then is to bring in predictive maintenance. That's all the time that we have for today. There are a couple of other examples of digital twins here. I hope that from this presentation you have seen that digital twins start with use cases, and based on the use case we can then design the digital twin. I'd like to thank everyone for your time and all the delegates and attendees. Thank you, Dr. Savari, for inviting me. If you ever have any questions or would like to discuss digital twins, please find me on LinkedIn. It's been a very great honor to be here today. Thank you.